Like to welcome you to our podcast over the solar system. We're going to start with the different models of the solar system. We actually started off with the Greeks thinking that the Earth was the center of everything. This is called the geocentric model. So we have the Earth in the center with the moon going around it, and then the planets themselves would orbit the Earth. This model held until 1543. We found out that it wasn't true. This held until Nicholas Copernicus published a different view. He discovered the heliocentric model, where the sun is the center of the solar system. And he stated that the moon is going to revolve around the Earth, and that the Earth and the other planets then revolve around the sun. And this was very controversial at the time. People didn't want to believe it. They were used to the geocentric model. But then a gentleman by the name of Galileo found evidence that supported Copernicus' view, and so then it was widely held that the sun was the center of the solar system and not the Earth. So this is what we agree with now. Then in the early 1600s, a gentleman by the name of Kepler discovered that planets travel around the sun in ellipses, not circles. Before this, we thought that everything traveled in a circular path, and he found out that no, things do actually travel in a ellipse pattern. And he came up with a couple of laws that we're going to be learning. The first law says that the orbit of a planet around the sun is an ellipse with the sun at one focus. Now here's an ellipse. An ellipse, remember, has two foci instead of one. So here's one, and the other foci would be over here. The sun is at one foci, and the other one is just empty. And so planets travel in an elliptical pattern around these two foci. Now, he also said that a line joining a planet and the sun, so here's my planet out here at X, here's the sun. If I draw a line out to them, that the sun sweeps out equal areas in equal intervals of time. So the time it took my planet to travel from X to Y and the area that this imaginary line covered, this green area, it is going to be the same amount of time as the planet as it travels from A to B and the area that this covers. So we know this, that as planets gets closer to the sun, it is going to speed up, and so it can travel further in a shorter amount of time. And then as I get further away from the sun, my planets slow down. So the green area is equal to the blue area, and even though the distance is shorter from X to Y than from A to B, the amount of time that it took to cover that is the same. And then we've already talked about astronomical units. An AU is equal to the average distance from the Earth to the sun, which is roughly 150 million kilometers. And every planet, other suns, other galaxies, we all base on this astronomical unit in comparison from the Earth to the sun. This unit is about planets. So we have three different ways that we can classify planets. The first one is based on their size and other characteristics. So we have terrestrial planets and Jovian planets. Terrestrial planets are those that are similar to Earth. That means like land and Earth. So these would be Mercury, Venus, Mars, things that have rock and Earth that they would have on them. Jovian planets are like Jupiter. They're the big giant gas planets past the asteroid belt. The second way that we can locate or classify planets is based on location. We're going to have inner and outer planets when we talk about this way of classifying planets. The inner planets are those that are between the sun and the asteroid belt, and the outer planets are those that are beyond the asteroid belt. And you should all know where the asteroid belt is based on your condensed time scale that you made in class. The other way of classifying planets is based on inferior and superior planets. Inferior planets are those that are between the Earth and the sun, and superior planets are those that are beyond Earth's orbit. Here in class, we're going to be talking about inner and outer planets as our main way of classifying planets. So let's go ahead and look at those. Here are my inner planets. That's Mercury, Venus, Earth, and Mars. They are rock. They have an iron core. They have land. They may or may not have water or frozen water on them, but they are made up of rock. Okay? The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas planets. They formed further away from the sun, so they're going to be colder than inner planets. So they're going to have water vapor, ice, methane, and they do not have a solid core. So they are actually, even though they're very big, they are full of gas, and they do not have a solid core like an inner planet does. So this unit, as we talk about space, we're going to also be talking about galaxies, the sun, stars, but in this podcast we are mainly concerned about the heliocentric view of how we look at things versus the geocentric view, and looking at our inner and outer planets. Next time we'll be talking about the sun. Bye.